Welcome, everyone. If you're an 8th grade learner looking to unlock some serious math superpowers today, you are in exactly the right place. I am absolutely thrilled to be your guide through this explainer. Today, we're stepping into the really cool, slightly magical world of mathematical patterns and sequences. We're going to look at how numbers grow, how they change, and most importantly, how we can completely predict their every move. All right, let's dive right in.
Picture this. You're walking along a super long path, and someone stops you and asks, "Hey, what exactly does the 100th step of this path look like?" Now, the normal, incredibly tedious way to find out would be to take step 1, then step 2, then step 3, all the way up to 99, just to see what that 100th step is. Sounds absolutely exhausting, right? But what if I told you there's a literal math cheat code? A way to completely bypass all those middle steps and just jump straight to the exact answer you need? Well, that's exactly what we're mastering today.
Now, before we get deep into the numbers, I actually want to ground our lesson in this powerful quote from Habakkuk 2:2. It says, "Write the vision and make it plain on tablets so that he who reads it may run with it." You might be wondering, why are we looking at this in a math explainer? Well, it's because God really values clear instructions. He calls us to write out our plans clearly so others can easily follow them. And really, mathematical formulas are just practical ways to write totally clear, plain rules. When we write a solid formula, anyone who reads it can just run with it and solve the pattern.
Section 1. 2 ways to navigate. Finding your mathematical path.
Okay, think of yourself as a navigator. When you're navigating sequences, you have 2 distinct tools in your mathematical tool belt. Sometimes you just need to know the very next step, but other times you want to jump light years ahead. To read our math map, we have to understand our coordinates, and we use 2 very specific variables for this. First, we have n. This simply represents a term's position in the sequence. Think of n like the address on a mailbox. You've got mailbox 1, mailbox 2, mailbox 3, and so on. Then we have an, which we read as a sub n. This is the actual number living at that specific position. It's the mail inside the mailbox. So if the third number in our sequence is 20, n is 3, and an is 20. Keeping these 2 straight, that's your secret weapon for mastering sequences.
So let's look at how these 2 navigation tools contrast, because they're really quite different. First is the recursive formula. This defines each term using the previous term. It's kind of like a set of old-school turn-by-turn directions. It essentially says, to get to the next number, just do this one specific thing to the number right before it. It's reliable for sure, but man, it is slow if you want to go far. Then we have the explicit formula. This is your direct shortcut. It doesn't care at all about the previous number. It only cares about the position, n. It's exactly like plugging direct GPS coordinates into your phone. You completely bypass the journey and arrive right at your destination.
Moving on to Section 2, Arithmetic and Geometric Sequences, Seeing the Formulas in Action. Let's see what happens when we apply these tools to actual numbers.
First up, arithmetic sequences. These are your steady, reliable patterns. They grow or shrink by a constant pace of addition or subtraction. Think of walking up a flight of stairs, where every single step is the exact same height. You're either adding the same amount every time to go up, or you're subtracting the same amount to go down. The absolute crucial point here is that the difference between any 2 consecutive terms is always exactly the same.
Take a look at the sequence on the screen. 4, 7, 10, 13. We are very clearly adding 3 every single time. Look at the recursive rule in that middle column. It gives us our starting point, a1 equals 4. Then it gives us that turn-by-turn rule, an equals the previous term plus 3. It's building the sequence one step at a time. But now, check out the explicit rule in the right column. an equals 3n plus 1. If we want the 4th term, we don't even need the 3rd term. We just plug in 4 for n. 3 times 4 is 12, plus 1 is 13. Boom! A direct jump to the answer.
Next, we have geometric sequences. Unlike those steady stairs of arithmetic patterns, geometric sequences leap. They accelerate rapidly because they grow or shrink by multiplying or dividing by a constant number. Instead of walking, you are suddenly zooming forward. If you're tracking a population that doubles every year, or a bouncing ball that loses half its height with every single bounce, you are looking at a geometric sequence.
Let's trace one together. 2, 4, 8, 16. It's doubling, right? The recursive rule sets our start. a1 equals 2. And the rule for any term, an, is just the previous term multiplied by 2. Just step-by-step doubling. But look at that explicit GPS shortcut. an equals 2 times 2 to the power of n minus 1. Let's test it to find the 4th term. Plug in 4 for n. 4 minus 1 is 3. 2 to the power of 3 is 8, and 2 times 8 is 16. It works perfectly, and it gives us the power to find the millionth term without having to calculate the 999,999 terms before it. Incredible, right?
This next one brilliantly illustrates the core concept one more time before we do some practice. Look at this really simple sequence. 5, 10, 15, 20. We're just counting by fives. The recursive rule takes two whole lines. You have to state the start, A1 equals 5, and then state the step, which is add 5 to the last number. But the explicit rule, it's just one elegant, simple equation, AN equals 5N. Want the 20th term? 5 times 20 is 100. Simple, clean, and honestly incredibly powerful for analyzing these patterns deeply.
Section 3. Test your new skills. It's time for some interactive homework, so grab a piece of paper and let's get into it.
All right, here's your very first challenge. Look at the sequence, 3, 6, 9, 12. Ask yourself, how exactly is it growing? I want you to write down both the recursive rule, that's the step-by-step directions including your starting point, and the explicit formula, the direct shortcut. Go ahead and pause the explainer right now and work that out.
Welcome back. How'd you do? Okay, let's look at number 3 from our assignment. Give a recursive rule for the sequence 81, 27, 9, 3. Pay really close attention here. The numbers are getting smaller. Are they stepping down by subtracting the same amount, or are they leaping down by dividing? Figure out that pattern, state your A1, and write the step-by-step recursive rule. Pause the explainer and try it right now.
Awesome job! Now let's try an explicit formula. Look at this sequence, 10, 20, 40, 80. It's clearly a geometric sequence because it's leaping forward, doubling every single time. Your challenge here is to completely bypass the step-by-step rule. I want the shortcut. Using n for the position, write the explicit formula that would let me jump straight to the 50th term. Pause the explainer and write it out.
Fantastic work today! Here is the ultimate review question to wrap up our math segment. In your own words, what is the core difference between recursive and explicit formulas? If you were to explain this to a friend who missed today's lesson, how would you describe the difference between mapping a journey step by step versus handing someone direct coordinates? If you can articulate that, you have truly mastered today's big idea.
Section 4. Education, Morality, and Peace, Becoming the Godly Learner.
As we wrap up the mathematical portion of our explainer today, I want us to slow our pacing down for just a moment to look at the bigger picture. We've learned some really powerful tools today. But the curriculum we're exploring, the heroesmartacademy Godly Learner series, recognizes that tools and knowledge are only part of the equation of life. The core philosophy we're concluding with is simply this: education without morality will hurt. Just think about it. What's the point of being incredibly smart, of knowing the most complex explicit formulas and being highly educated, if a person continues to make bad choices that hurt themselves and the people around them? Mathematical rules bring order to numbers, sure, but moral rules bring order, safety, and purpose to our actual lives. Knowledge gives you power, but morality gives you the wisdom to use that power well.
And that brings us to our final thought. The curriculum highlights a really beautiful promise found in Romans 8:6-7, which states that keeping your mind spiritual brings life and peace. A truly godly learner doesn't just seek to be smart, they seek to be wise and spiritually focused, because that is where true peace of mind is found. So, as you go out and navigate the sequences of your own life this week, my challenge to you is this: will you seek both the knowledge to understand the world and the moral wisdom to make it better? Thank you so much for joining me for this explainer, and keep learning.